Hello, so we're going to be talking about 3.2, adding and subtracting polynomials. It's actually very similar to adding and subtracting integers with a few differences. For one, you can only combine like terms. Now, what are like terms? Like terms are terms that have the same variables and degrees. So if we take a look at our polynomial, remember, x is our variable, and these two are constants, 4 and 10. But remember, we can also write them as x to the 0, x to the 0, so the variable is still x, and our degrees would be just the exponent we're raising x by. So 0, and these, it's not written, but it's 1. Okay, so if you look at our integers, we have 5 minus 2 plus 1 minus 9 plus 10. We can actually combine all of them to get 5. But for polynomials, we can't combine just any term. We can only combine like terms. So those are the ones with the same variables and degrees. So 2x squared and 4x squared are like terms because they have the variable x and a degree of 2. And negative 2x and x are like terms because they have the variable x and a degree of 1. And 4 and 10 are like terms because they have the variable x and a degree of 0. So our answer should have a term from these two, another term from these two, and a third term after we combine these two. Okay, so our answer, this leads into our second difference. Our answers are polynomials written in descending order, right? So for integers, our answer is just a whole number, but for polynomials, our answer will be a polynomial and it'll be written in descending order, and you'll see what that means as we get into an example. So let's get into our first example, adding polynomials. So first thing you want to do, what I recommend you do, is that you make sure your polynomial is written in descending order. What does that mean? That means the term with the highest degree will be written first, and terms with fewer degrees will follow. So x squared has a degree of 2, 3x, remember, has a degree of 1, and our constant, remember, constants have a degree of 0. So you see we go from a degree of 2 to a degree of 1 to a degree of 0. So we are in descending order, or as we called it in the last video, standard form. Same thing here. We go from a degree of 2 to 1 to 0. Next, we want to identify our like terms. Remember, our like terms have the same variables and degrees. The and is very important. They need to have both that are the same to be considered like terms. So let's identify some. X squared and 5x squared. These two are like terms because their variable is x with a degree of 2. Now we have negative 3x and 2x. They both have a variable x and a degree of 1. Remember, it's not written, but it's implied. Lastly, our constants, negative 4 and 1. These are like terms. Now, all we have to do is just combine. Now, I'll write it out explicitly. X squared plus 5x squared. Negative 3x, that negative is important, and 2x. Lastly, negative 4 and positive 1. Now, Apex says that you can solve this in two ways, whether it's horizontally or vertically. In this video, I'm doing it horizontally, but you should do whatever is more comfortable for you and just whatever makes it easier for you. So now we can combine our like terms, x squared plus 5x squared. Remember, x squared is actually just 1x squared. The 1 is implied, we just don't write it. So what does this actually give us? 6x squared. The variable and the degree do not change. It's still x and it's still a degree of 2. The only thing that changed was the coefficient. 1 plus 5 is 6. Alright, next, negative 3x plus 2x. This would give us negative x. Same thing, variable and degree do not change. Lastly, negative 4 plus 1 to give us negative 3. So this is our final answer, a polynomial written in descending order. We go from 2 to 1, and remember, a constant has a degree of 0. So That's our final answer. So let's go on to an example, subtracting polynomials. Now this is exactly like adding, it's just that there's one extra step, and I'll point that out. Okay, so first, remember, we want to make sure we are in descending order. Go from a degree of 2, degree of 1, to a degree of 0. Go from a degree of 2 to 1 to 0. Good. Now let's identify like terms. 5x squared, 4x squared. Both have a variable x, degree of 2. 3x, negative x. They have a variable x and a degree of 1. Then our constants, 8 and negative 1. They have the variable x and a degree of 0. So now, let's talk about that extra step we need to do. What we actually have to do is what we call distribute. This is when we take this minus sign, and you see it's being applied to everything within the parentheses. So we have to take this minus sign and apply it to every single one inside the parentheses. Okay, and we call that distributing the minus sign. So that is the extra step. So now let's combine like terms along with distributing. So 5x squared minus, this minus is from here, positive 4x squared. Okay, next, 3x minus, this minus is from here because it has to go to everyone, minus, and we have a negative x, okay? Important. Do not forget it. Last is 8 minus, remember this minus is from here because it goes to everyone, and it's negative 1. Negative 1. So you see here, I actually combined all the plus and minus signs just so I don't get confused. So I wrote it all out so I can see clearly. So let's clean it up. 5x squared minus 4x squared. Sorry. And what is this? 3x. Remember, two negatives make a positive, plus x. Next, 8, two negatives make a positive. Oops, sorry. Plus 1. Now we can combine 5x squared minus 4x squared. This would just give us 1x squared. Remember, variable and degree don't change. 3x plus x is 4x, and 8 plus 1 is 9. So this is our final answer, a polynomial in descending order. We go from 2 to 1 to 0.